This video is on bivariate statistics. Bivariate data has two variables. What we have looked at previously is univariate, which just has one variable, and bivariate has two, which we can then compare to see whether there is a correlation between the two variables. Now we've got different types of correlation. We've got three examples here in these three different graphs. The first one is a positive correlation because it is moving in an upwards direction. The second one is negative as it is moving in a downwards direction. And the third one, we say there's no correlation because it doesn't appear to be going upwards or going downwards. The dots are kind of all just placed randomly. When we do talk then about correlation, we can also describe it as strong, moderate or weak. A strong correlation means all the dots, as you can see here in this first one, align very, very closely to a straight line. A moderate correlation is where we can see it is still going upwards or downwards if it was negative, but the dots are a bit more spread out from the middle of the line. And a weak is where we can once again still see that it's going from low all the way up to high, but the data points are definitely a lot more spread out. With correlations, we are just, with this section, looking at linear correlations, but you can also have a non-linear correlation as per this second graph here. But for just now, we are going to be looking at linear, which is like the first one. Pearson's product moment correlation coefficient which is also known as the R value, is a measure of the linear correlation between two variables, x and y, and it can take a value between -1 and 1. I've got just a little table here to help interpret the correlation from the R value. So anything between 0 and 0.25, whether it is positive or negative, because in the middle here we've got the absolute value of R, which means we're looking at the positive or negative of these values, will be classed as very weak. Between 0.25 and 0.5, positive or negative, it's classed as weak. Between 0.5, 0.75, moderate, and then 0.75 to 1 would be strong. When we have outliers, they are isolated points which do not follow the trend formed by the main body of data. If an outlier is a result of a recording or graphing error, we need to get rid of it. It can be discarded. But if it's a genuine piece of data, then we should keep it in. For example, sometimes you can have somebody, and a 13-year-old boy could really be 6'2" tall, a lot taller than the rest of his classmates, but it is still a valid piece of data because it is still true. Where if we recorded the height of somebody at, say, 9 foot, we know that's an error in our calculation or recording, therefore we can get rid of that piece of data. A few examples here. So example 1, we've got this table that gives test results in maths and biology for 8 different students. We're going to plot the data points on a set of axes first. And I've already got this done here for us. So I've got my axis and all those data points plotted. So maths is our X and biology is our Y coordinate. And B, we want to comment on any correlation we can see in the graph. In the graph, we can clearly see that the points are going in an upwards direction. Therefore, we would say it is positive. And then we can then say it's either strong or moderate. This is a personal kind of interpretation of what you see. I would say it was strong because majority of the points form a straight line. These two that are kind of off will probably not pull it down to a moderate, so I reckon it's a strong. But once we calculate the R value, or the Pearson's, then we will definitely be able to see if it's strong or moderate. Part C, we want to find the Pearson's product moment correlation coefficient, and then we want to compare it to what we thought in part B. So our R value, we're going to calculate now by going to our calculator. On the calculator, we want to go to a spreadsheet, which is the green button at the bottom there. Now we're going to put in our data. The first column is going to be our X, which is mathematics, and the second column, our biology, which is our Y. I've just put in both sets of data into the first and second column. To find our R value, there's different places you can find it on the calculator. This is the place that I always go to. We go to Menu, Statistics, Stat Calculations. Now with this, I want you to always go to number 3, Linear Regression, which is going to come into what we do next. Now you can see here there's two linear regressions, an mx plus b and an a plus bx. I want you to always go to the mx plus b, because in something else we're going to do, that will mean that you shouldn't make any mistakes or lose marks. Put in our information, so our x coordinate is in column A, so we need to change that to an A if it's not already. Our y coordinate is in column B, so B and then control open bracket to get the square brackets. We leave the rest and we just want to check our results column at the end, and we can see there that is in C, which means it is all good. And we have our values. There's lots of other information here. The one we want is R. Now you see there's an R squared here and an R here. We want just the R value only. So this value here, the 0.87299. One big mistake people make in an exam is they write R squared, as other subjects such as biology often use that value, but in maths, in AISL, we just look at R. Just going to write our R value in here that we've found, which was 0.8729902. And if we round that to 3 significant figures, we get 0.873. And we can see there it is 0.873. If we go back up to this quick table here, we see it falls into this last bracket, and therefore it is classed as a strong correlation. Next section, the line of best fit. A line of best fit is a straight line drawn through the centre of a group of data points. If we were ever to draw this by hand, we must first calculate the mean point, which is us finding the mean of the x values and the mean of the y values. We then plot this point on the scatter plot and draw the line of best fit. Now our line of best fit has to go through that mean point that we've just added to the graph. When you have a line of best fit, you can use it to find estimates about the data. We've got two types of prediction: interpolation, which is where we are looking for an estimate that's within the data range we've been given in the question. Then we have extrapolation, which means we are trying to predict or estimate a value where our x is outside of the data values that we were given in the question. This is often considered unreliable and we should not be using it to predict. Let's have a look at this example, which matches the one we just did before with the scatter plot, so we will be going back up to there in a second. We've got that data, the same data we just had previously, but this time we want to find the mean of the maths results and then the mean of the biology test results. We're going to do this on our calculators. Now, if you're not sure how to find the mean using your calculator, then please go have a look at one of my other videos on measures of central tendency, and I show you in there how you can find the mean of a set of data. But once we do find the mean, we get that that is 32.75 or 32.8 to 3 significant figures. And then our mean of the biology test results, when you find that, you get 25.375, which is equal to 25.4 to 3 significant figures. Now part C, we want to plot and label the mean point on the scatter diagram and use it to draw a line of best fit by eye. I want you to go back to your scatter plot you've just drawn before, but I've got a duplicate here for me to do on here. You don't need to redraw the scatter plot. Please just go and draw on the one you created in the last example we just did. Now we want to plot and label the mean point. So our mean point are the two values we just found for the mean. So our coordinate would be 32.8 and 25.4. And we need to plot that value. So I'm going to do that in blue. And you'll find it's going to end up somewhere about here. You see that blue dot I've drawn. Now when we draw the line of best fit, the line has to go through that blue point, and we've got to draw it as close to the middle of the data as possible. Now in a line of best fit, what we're looking for then is approximately the same amount of dots above and below the line of best fit that we're drawing to try and get roughly in the middle. And you can see that that's what I've just done there. Then part D, we want to predict the biology test result of someone who got 40 in their math test. So we look for 40 in the math test, which is our x-axis. We are going to go up to our new line of best fit, that's in blue. And then we're going to read across to the y-axis to get an estimate of that value. And I'm going to say that looks like it's approximately 28. Alright, next example. At a coach station, the maximum temperature in degrees Celsius is our x coordinate, and the number of bottles of water sold, our y, were recorded over 10 consecutive days. The collected data is summarised in the table. So you can see we've got day 1 to 10, and then the temperature and how many bottles of water were sold. First of all, we're going to plot data points on a scatter diagram. Now, I'm not going to get you to draw the scatter diagram here, but what I will do is I'm going to show you how you can draw a scatter plot on the calculator. On the spreadsheet, we're going to put all the data in that we need. Now, we just want the x and y's, the days don't matter, we just want the x and y data. I've entered all the data. Now, to draw a scatter plot, we do need to label our columns. So if you just go to the top here and you see we've got A, B, so next to the A, in here we can edit this to label the column. I would recommend not using X and Y or other just single letters, as it can sometimes get confusing if you're using those variables later on, because it's got information stored under that letter. So because this is temperature, I'm just going to call this column temp, and then the B column is water bottles sold, so I'm just going to maybe call that water, just so I know which is which to help with the scatter plot. Once we've got that in, we're actually going to go back to the home page, and next to the spreadsheet you see this purple square that has got a graph in it. So you select this, we've got some points. This isn't quite ready yet. On the x-axis you can see this click to variable, click on that, and the variable that was our x was temperature, so we click that there. Then we go to the y-axis, go to click add to variable, and the y-axis was water, so we can select that, and then you can see we have a lovely scatter plot drawn. Now part B of this question is comment on the correlation. Once again, we're going to look at this and do we think it is positive or negative? As it is going upwards, it will be positive. But then is it strong or moderate? I can see arguments for both sides, so you just make your assumption on what you think it is. If it was ever asked of you in an exam to comment on a scatter plot correlation, usually it's done in a way that it is very much a strong or a weak, because it's less open for interpretation. Part C, find the equation of the regression line of y on x. Now we're going to go back to our spreadsheet. And to find our equation of the regression line, if we go to menu, statistics, stat calculation, and once again this number 3 linear regression, mx plus b. Fill in all the details here that we need. Okay, we're just going to go back up to the top once we've got our information. Now you can see here we've got a regression equation of mx plus b. And so here's our m value for this situation and our b value. And that is what creates our equation. So our regression equations are always in the form y equals ax plus b. That is how the IB often describe a linear regression with a and b there. On our calculator, we have gone to the y equals mx plus b category because this gives us our values in the correct order that we want them. And when we get the information that we just saw on the calculator, we get y equals 8.05x, because that was the value of m, and minus 24.7 because that was the value of b. Now part D, draw the regression line on the scatter diagram. On your calculator here, go back to the scatter plot, and to draw our regression, go menu, analyze, and then number 6 regression, and we want the show linear mx plus b because that's the form of the equation we want here. If you look at the next one, it is a plus bx. And so sometimes if people go to this one, they get the a and b value the wrong way around as with how we are asked to give our answer in a question. Therefore, this is why I've always said go to the mx plus b. And you'll see here, then the regression equation just appears on the screen for you. And we've got their y equals 8.04554x minus 24.7476, which is what we got in the spreadsheet. And finally, part E, the temperature is predicted to be 19.5 degrees Celsius. Estimate how many bottles of water should be stocked. We have our regression equation from part C. So from here, all we're going to do is sub 19.5 into this to get our answer. Now it's always better to use exact values in our calculations rather than a rounded number here. So we're going to go back to the calculator again. And I'm going to go back to my table. In our table here, we're not going to write down the numbers or anything like that to take them anywhere. We're going to use our spreadsheet and utilise it to the best of its ability. So remembering this works just like Excel. So we want y equals 8.05 multiplied by 19.5. So we need our equals, and we want our m value, which is in D3. So you can either select D3 or write D3 into the box there. And we want to multiply that by 19.5, which is the temperature we were given in the question. Then we want to add our B value, which is in cell D4, or you can select D4 to put that number in there. Press enter, and then you can see that we will be estimating that we will be selling 132.14 water bottles when it is 19.5 degrees Celsius. So the question is asking us to estimate how many bottles of water should be stocked according to this regression line. We have found the answer of 132.14, but we can't stock 0.14 of a water bottle, which means to make sure there is enough water, we will need to stock 133 water bottles, as per our regression line, 132 may not be enough. A random sample of 12 students is taken to see whether there is a linear relationship between height in centimetres, our x, and shoe size y. The data collected is shown in this table. First of all, we want to find the R value and comment on the correlation. Let's go to the calculator, put the data in our spreadsheet and get the R value. I've put all the data in. Let's go find our R value. So menu, statistics, stat calculations, linear regression mx plus b. Get our data, look for the R value, and here remember we want the R, not R squared. So our R value is 0.853563. And then from there, if we went back to look at our table, we can then see that 0.854 to 3 significant figures would be classed as a strong positive correlation. Part B, explain why it is appropriate to find the regression line of y on x. When we are creating a regression line, it is only appropriate if we have a strong positive correlation, because it means it's very close to being linear. It means when we put it on a scatter plot, all the points are quite close to a central line that goes through them. They're not too spread out. Therefore, it's showing it is fairly linear in its shape. Therefore, we can do a regression line, because a regression line is in the form of y equals mx plus c, which is linear. So we can do a regression line of y and x because the R value shows it is a strong linear correlation. Part C, we want to find the regression line. Back to our spreadsheet, if we just scroll back up, we went into this, find the R value, because we already have our M and our B here ready for the regression line. So we can then put those values straight into our answer. Therefore, our regression line would be y equals, our M value from the calculator was 0.154007x, and the B value was 11.9975. And then to 3 significant figures, 0.154x plus 12.0. Part D, estimate the shoe size of a student who is 163 centimetres tall. So y equals 0.154. X is our height, so that will be 163 plus 12.0. Then we want to explain why this is a valid process. We'll calculate it first and then we'll do the explanation. And let's do what we just did before. So equals our M value times by our height that we've been given, which is 163, plus our B value, and enter, and we get 37.1006. So we are estimating y to be 37.1006, which is 37.1 to 3 significant figures. Now, why is this valid? It's valid because this 163 that we're subbing in, just go back up to the data, fits within our range of data that we've been given in the question. So in the question, our smallest value is 160 and our largest value is 187. Because it's between those two values, It's a valid process for us to be able to estimate the shoe size of somebody who is 163 centimetres tall, because it is interpolation. 163 is in this range of data. Part E. Explain why it is not reliable to use a regression line of y and x to estimate the shoe size of a student who is 150 centimetres tall. Now 150 centimetres is smaller than our smallest eye of 160. Because it is smaller, it is not within the data range, therefore it cannot be classed as reliable. So the 150 centimetres is beyond the data range. And that's an example of extrapolation. Part F, explain why it is not appropriate to use a regression line of y and x to estimate the height of a student whose shoe size is 38. So when we use regression lines, we can only use a regression line of y and x to estimate y based on the x. So the x-axis to estimate the y value, the y-axis. So if we want, because our shoe size is our y, we can't use our shoe size of y to estimate the x. If we did want to do the shoe size to estimate the height, then we would need to find a regression line of x on y instead and use that. So here we're just going to write the regression line y on x should only be used to estimate the values of y when x is given. And that's the end of this video.